Hi guys, Shouvik and welcome back to YouTube channel. So today we will solve another question from Leetcode itself. So let's get started. Yes, so today we have these problems: convert binary numbers in a linked list to integer. Yeah, so this problem tagged as an easy and I feel so it's an indeed super easy problem to solve. But yeah, like there can be follow-ups to a particular problems and we are going to solve it to what is the maximum follow-up you can expect in any interview perspective. So although the problem is easy tag, but based on the follow-ups, easy problems can be a very good medium level problems for sure. Yeah, so first let's try to understand the problem statement. So what they have given us, they have given a head of a linked list, head of a single linked list. So there are two linked lists. One is a single linked list and another one is a double-ended linked list. So for double-ended linked list there are two pointers, like from particular node there is a next pointer and there is a previous pointer, but we don't have to go to that double-ended linked list because that this problem is very straightforward. That is for single linked list, and for single linked list there are the class levels of a single linked list. It has a value and it has a next pointer. That's it. What is the constructor they have given us? You can see on the list node, right? So the value of each node in the linked list is either 0 or 1. The linked list hold the binary representations of a number, right? So the linked list they have given is the binary representations of a number. So return the decimal values of the number in the linked list. So what we have to return? We have to return the decimal value of the number in the linked list. The most significant bit is at the head of the linked list. So that is the thing. So here you can see 101. So if we are going to write it in kind of a binary, it becomes 1, 0 and 1. And what is the decimal for it? It's 5. So this is another linked list where head equals to only 0 and this represent and its corresponding binary is going to be a 0 only. So now I'm just quickly iterate to you guys to the these things, that is of how actually we are doing a decimal to binary things. If there is a binary is given, then what is the corresponding decimal for it? So on the given example test case, they have given to us a strings that is of 101. So and they have given to us from most significant to least significant. That is, the head of the linked list is pointing to the most significance and corresponding to its right part is the least significance. But when we are trying to convert, so that is in binary. So if you are trying to write it corresponding decimal format, then we have to start from its back. So this is very basics. I feel you guys is already know from a binary to decimal conversions, but whomever is not aware of this, so I am just quickly iterate to you guys to that. So we are iterating from least significant bit to most significant bit to the binary, and we are starting if whatever the value to it 1. So here it is 1, right? 1 into 2 raised to the power current index. So we are starting the index from 0, right? So for this, so that is the contribution to its decimal. For this, what is the current value? 0 into what is the index value? 2 raised to the power 1. We are starting from 0, so that is of 0, that is of 1 and that is of 2. Then another index is current bit is 1 into 2 raised to the power current index contributions, current index is 2. So this, and now we have to do the plus of this. So 2 raised to the power 0 is 1, this is of 0 and this is of 2. So this is of 4. So 1 plus 0 plus 4, the outcome is 5. So you can see on the example test case the outcome was 5. Now let's take another example test case, that is of 1 1 0. Let's suppose that is the linked list they have given to us. So that is a linked list, right? Now what we have to do, we have to start from here, 2 to the power 0 into 0, then 1 into 2 to the power 1, right? Then for this 1 into 2 to the power 2, 4 plus 2 plus 0. So that is of, if I am starting from first, 4 plus 2 plus 0, so that is of 6. Now if I can quickly run it for the same example test case, I can quickly add one more example test case for it, and I am taking it to 1 1 0, and if I can quickly run it, so it should give me 6, right? Yes, it is giving me 6. So that is what we have just saw. So what actually they needed, so I am not going to the brute, because on brute what you can do, you can just iterate from left to right. So maybe just quickly discuss the brute. So you can just iterate to your linked list and store the value whatever you are getting to a string. So you are iterating from 1 then 0. So you are basically storing 1 1 0 to a string, or this can be a string, this can be a list, anything. And now you just have to so that is the binary value, that is the binary you have stored, and now to convert it decimals you have to iterate from its reverse. You have to iterate from its reverse, that is from right to left. And you can take a counter variables, you can start it to be 0, so that is the current index it is basically mentioning, and you can do the games current value into 2 raised to the power cnt, that's it. And similarly, like for this 1 into 2 raised to the power cnt, and for every iterations increase your cnt to be plus plus. But yeah, that is exact, that these things we are not going to do, because that is going to consume another extra space of big of n. The space it is consumes is big of n. So we are basically looking for a solution which is going to run in a constant space, that is of big of 1 space. So what actually the challenge? If I am going to ask you, if the linked list is given to from least significant bit to most significant bit, what they have given to us from most significant bit to least significant bit. So that's the reason. But we, to calculate its binary to decimal, we have to iterate from least significant to most significant, but they have given to most significant to least significant. So we have to iterate from its reverse. So if the linked list is given to us in reverse pattern, in from least significant bit to most significant bit, then does our job is done? Do you guys feel so? Yes, obviously, Shouvik, obviously. So now then what is coming to your top of your mind at very first go? Can we reverse the current linked list? So that is the most commonly asked interview problems, to reverse a linked list. If we are going to feed that algo, that is what we will do. Then what is the steps is coming to our brain after getting these hints? The first is reverse the linked list. So then it is basically giving me its current patterns then becomes least significant bit to most significant bit. Then on point 2, iterate. Simple iterations we can do on the reverse linked list. Standard linked list iterations we can do, and do the current value to the power 2 raised to the power cnt. That we can do on the reverse linked list, right? So the problem becomes very straightforward, very simple now. So now we have to just to write the reverse linked list pseudocode. So I am going to directly explaining to you the code iterations, but before that, let's do a dynamic walkthrough of how actually reverse a linked list is basically working in the actual like code iterations runtime. So every video you will going to get, everyone's just writing the reverse of the linked list code, and they are basically explaining to you line by line. But I am not going to do that. I am basically giving you how actually the reverse linked list pseudocode is basically changing the pointer, because when you are going to get the feel of how you have to play with your pointers, then you are actually feel you are by default consume the code. The consumption of the code or the digest the code is not actually the tricky part. The tricky part is how actually the node pointers we have to play. If you understand the game of how we have to shift the node pointer, then digest the code, that is actually be a cakewalk for you for sure. So now I am just going to open my Miro and try to explain you how we have to play our games to reverse a linked list. I am taking the example 110 because I am not going to like a big fan of 101 example discuss, because on forward and backwards it's become same only. So let's just quickly create our linked list. So the first one is 0, and if I am going to create some clone of it, Ctrl C, Ctrl V, Ctrl V. So we have 2 clones created. The last one should be of 0. And what is the initial configurations we have given to us? It's this, right? Is this, then this to this, be a little bit format. Yes. So that is the given linked list, and here our head is at this. So here our head is. So now to reverse it, try to digest the steps. We need 2 pointers. We need 2 pointers to initialize, and then we should be very good state. So define this index, define this to be your pref, and define this. So first of all, if we have a single head altogether, do we have to do anything? Nope. So the very first checks on your code, just make if your head.next is exists. So that means there is at least 2 node present. Then only reversing is making any sense, right? If there is only single node, then is reversing is making any sense? Nope, nope. So that's the reason. I'm just parallelly explaining the code also. If my head.next is there, then only you have to reverse the linked list. Otherwise, you can skip it. If there is only a single head, then it is not making any sense of for reversing, right? So that is the extra checks. If there are at least 2 nodes, then just initialize like this. And my current node, let's point to this. That is my head at prev and my current at head.next. Now, what you can do, let me take one more node for 2 so that you guys can get a better gist of it. Let's suppose this is 1, right? And there is a node pointer from here to here and this. Now what we can do, we are going to go to a while loop. We have to do in a iterations for sure. And we can do, when we add this index, when we add this current, at the very beginnings, make this as we add this current node. When we are at current, what is the if I can open a sticky note, what is the things we have to maintain? What is the things we have to maintain? Can I drag it some a little here? Yes. So the steps should be on the current node, we have to create a link to its previous. Create a link from card of next to its previous, to its prev, and prev is basically holding its previous. So that is the games we have to play. That is the games we have to play to every iterations we are doing. So that is the steps we just, only single steps you just have to follow. So when we are at current, so and one more like initial configurations we have to take. This head.next, you can make it to be a dangling, so that because we are at current node, right? From current node we remove this node pointer and pointing to its previous, right? So this node you can get rid of. So if you are not getting it, let's skip it. We can do our iterations very fast. So our current it here. So what we are stating this current of next, what it is mentioned, its current of next should point to its previous. So this current of next, this pointer should point to its, is it happening or not? So this should point to its previous, right? So this we need. Now when we did it, at the same time, before doing it, sorry, let's not do first. When you are in your while loop, let's take, because when you are doing this node pointer transition, you are going to get this node pointer altogether, you are going to get rid of. So before doing this, please store your next pointer reference to a nxt variables. So we have then 3 variables set, prev, cur, next. Now you are at very good state to play the game that you are playing. So here we are doing this node of current of next. So current of next previously pointing to next. Now current of next is pointing to prev. And so that is one point. Move your current. Before moving your current, move your previous to current. So now previous becomes here. Then move your current to next, right? So that is on iterations, on a particular iterations, this game you have to do. Again, define your next. My next should be current of next. My current is here, so my next should be at here, right? Now after doing that, this, sorry, not this node, that is my current of next, should point my previous. Where is my previous? Previous is point to here. Move it to here. Moved. Move your current and prev. First move your prev. Prev should be cur. Cur should be here, right? And every node by default should have a none node. If I can quickly draw a none node here. So at the very last we have a none node. So this node is pointing to none node. So we have to iterate until our current node becomes none node, right? Our current node becomes none node. So it's still not. So we had at this configuration. So define your next. My next becomes now none, right? Not current. My next becomes none, right? Next definitions done. Move pointer. Moving. Moved. Pointer moved. Move your previous to current, moved, move your current to next, moved, my current becomes none. So you are break from your while loop. You are break from your while loop. So when you are break from your while loop, just make sure you are pointing your head to be brave, because my previous now pointing to the very last nodes where we have my current value is present. So this is because now my current becomes none and my previous is holding this value. So when you are break out, after breaking it, just move your head node to this node. So whatever your previous value, move it to your head. Now, is it our reverse linked list? Yes, but just a small cycle is formed here where because we have start from this particular current node, so this node actually missed out. So when you are just at the very start of your configuration initializations, so our head becomes here. So just make your head of next to be none. So just makes this pointer to pointing to none. So in very straight terms, you can delete this pointer. So head of next at very initial configurations, make it head of next equals to none, so that this node pointer is altogether at very starting we have get rid of, and we are starting our previous here, our current here, and next we will define to our while loop iterations by following these principles. Yes, exactly these things you have to do to reverse a linked list. Now we can quickly go to our code iteration. So we need two variables, previous and card. Prev should be my head, card should be my head of next, and head of next we are make it to none, so that we are not going to like have some cyclic dependency or cyclic transitions node to be pending to our bucket. So that's the reason of the very start, where at the very initial configurations we are making that head of next to be none only. Now we are doing the exact same things while my current to be present. Next we are defining card of next. Now card of next should point to previous. My previous then becomes card. My card should becomes next. The same transitions we have saw. And finally, after the entire iterations we have done, which actually pointing to my head node, then on the reverse linked list, it's brave. So we are storing my head value to be brave. And now, very simple game. Now we just have to iterate to the reverse linked list. We have reverse linked list built, and reverse linked list head is pointing by this head pointer. Now do the standard iterations. Now while my head answer plus equals to head of val, what is the val? If it is 0, then it is going to be neutralized. If it is 1, then that value into 2 raised to the power the current index contributions. We are starting from 0 and we are keep on increasing, right? Because we are iterating now in reverse linked list. Now head equals to head of next, count we are increasing, and finally we are returning our answer. Yes. The problem is as simple as that, guys. And I would highly encourage you guys to give this solution only on interview, because any question asked on an linked list base, you should have to play your entire games on in memory. You are not allowed to define any extra space. And on this example discuss, we are on this example solutions or this particular approach, we are doing that only. We are not define any extra space. We are playing the entire games to in memory, and we have showed our grip to the interviewer that we are very comfortable to do a reverse linked list code in just a cakewalk kind of things. So that's exactly the intentions of an interviewer to check are you able to reverse a linked list or not, if by chance you are going to get these problems to an interview. So that's the reasons on very initial I am stating it's not an easy, based on how we are going to approach, how you are basically approaching a particular problems. If you are storing it to a linked list or a string, then it becomes a super easy things. But if you have to play your entire games in memory, then it's a kind of challenging for sure, how you are basically playing your node pointers to it. Yes. So now we can quickly discuss the time complexity. So on time complexity, we are doing couple of past iterations. Reversing a linked list is big of n for sure. Then we are calculating our answer. So it is a big of 2n for sure. And on space complexity, do you guys see we are using any extra space? Nope. That is the beauty we have incorporated to our solution. It is a big of 1 space for sure. So you can see our submissions is altogether 100% faster than all the submissions over the Leetcode, and on memory perspective also it's a constant for sure. If we can ask, can you predict, man? Yes, it's a big of 1 space complexity. And time complexity, it will give big of n might be. Yes, it is giving big of n, but exactly it is big of 2n. Explicitly mentioned to your interviewer that we are doing couple of passes, forward pass to basically reverse it, and on the reverse linked list we just a single pass to calculate our answer. So that's the reason it is big of 12. And space complexity, you are the best guys of that particular interview for sure. Yes, so that's all about this particular problem solutions, guys. And if you guys are able to understand till this point, I guess you guys are already, so please do subscribe to our channel. Please share the videos to your friends circle who are also preparing for top product based company and brushing up their user skills. And please turn on the notification so that when we are going to live to our next video, you guys are going to get the notification as soon as possible. So that's it, guys. That's it for today. Let's meet next day with another video question. Bye, guys. Bye.